This is a big class. We should have 30 of us here. We've got currently like 19 students in here. So we're still missing a few. But welcome to March. Hey, it is March now. So things are moving right along. That means it'll be spring break very shortly. And once spring break gets here, like summer is just real quickly. Go ahead, Piper. Real quickly, right around the corner once we get to spring break. So if you are behind on assignments, now is the time because things will get quicker from here. It's like zip, 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 and suddenly you're looking at the end of the semester going, oh, what happened to all my time? Don't get real far behind if you're missing things. Like I said, these matrix assignments, I usually see grades come up because they're quick, they're pretty easy to understand, and generally do pretty well in getting up there. So it was an interesting weekend. I can kind of think that we took two different weekends and we spliced them together because we had this beautiful 80 degree sunny weather day on Saturday. It was gorgeous to go do whatever you want. And then Sunday it was like in the 50s. It was rainy. It was kind of like, okay, I don't want to stay outside. I'm cold now because I'm wet. So it was like two entirely different weekends just stuck together to be all at once. So kind of weird, but it's all right. My oldest daughter's in town from New Jersey. I was excited. She's staying at our house tonight, and so she'll be here another couple of days. So good weekend at my place. Played a lot of games this weekend since she was in town. So hopefully you're making the most of it. But 3 weeks. I just need one of these. 3 weeks till spring break. Got this week, next week, and a week after. So we don't have a whole lot of school left till you get an extended break, which always excited for an extended break. You think a supersized weekend's great? Wait till we supersize it to wrap around 2 weekends. We'll get there. Okay, well we're going to go ahead and get going. Anyone else that's absent may not make it. I don't know. We'll get going and let them catch up if they can. Looking in Buzz, let's pull this up on the screen. Third period, let's go to grade screen. Of course, we finished Module 5 a couple of weeks ago. Now we had the week of the 22nd, matrix dimensions, matrix elements, representing linear systems. So yeah, when you click on these and it takes you to that link, that's the same place you turn it in, that same page. We'll look at that again. Last week we had the matrix row operations and the quiz. This week, we got 4 things this week, and then we'll take a quiz next week. So add and subtract matrices. I should have just bumped them to be at the quiz. That's okay. Add and subtract matrices. So we're doing 2 folders. Week 27, adding and subtracting matrices and multiplying matrices by scalars. And next week we'll have our finishing quiz. And I think we'll be done with matrices at that point. But let's see. Yes, that's it. Week 28 is our last week. We'll have 1 lesson in the quiz next week. So, all right, this week there are 2 folders. You want to do everything in week 27, adding and subtracting matrices. We have a video and a lesson, and then 2 assignments. Then we'll have another video and a lesson with 2 assignments. So let's start with our first video. Go to this link. Since it's a video, I need to make sure you can hear it.
Let's think about how we can define matrix addition. And mathematicians could have chosen any of an arbitrary number of ways to define addition, but they've picked a way to define addition that seems, one, to make sense, and it also has nice properties that allow us to do interesting things with matrices later on. So if you were one of these mathematicians who are first defining how matrices should be added, how would you define adding this first matrix over here to the second one? Well, the most common sense thing that might have jumped out at you, especially because these 2 matrices have the same dimensions. This is a 2 by 3 matrix, has 2 rows and 3 columns. This is also a 2 by 3 matrix, 2 rows and 3 columns, is to just add the corresponding entries. And if that was your intuition, then you had the same intuition as the mathematical mainstream, that the addition of matrices should literally just be adding the corresponding entries. So in this situation, we add 1 plus 5 to get the corresponding entry in the sum, which is 6. You can add negative 7 plus 0 to get negative 7. You can add 5 plus 3 to get 8. You can add, and I'm running out of colors here, you could add 0 plus 11 to get 11. You can add 3 to negative 1 to get 2. And you could add negative 10 plus 7 to get negative 3. And if you see this definition of matrix addition, you see that it actually does not matter in what order that we actually add these matrices. I could have done this the other way around. If I did this the other way around, let me copy and paste this. So if I were to add this matrix, so let me copy and let me paste it. If I were to add it this way, that matrix to, let me copy and paste the other one, to this matrix. So copy and paste. If I were to go this way, you'll see that the order in which I'm adding the matrices does not matter. So this is just like adding numbers. A plus B is the same thing as B plus A. What we'll see is that this won't be true for every matrix operation that we study. In particular, this will not be true for matrix multiplication. But if you add these two things, using the definition we just came up with, adding corresponding terms, you'll get the exact same result. Up here we added 1 plus 5 and we got 6. Here we'll add 5 plus 1 and we'll get 6. We get the same result because 1 plus 5 is the same thing as 5 plus 1. Here we had 0 plus negative 7. You get negative 7. So you're going to get the exact same thing as we got up here. So when you're adding matrices, if you were to call this matrix right over here matrix A, which we normally denote with a capital bolded letter, and you call this matrix right over here matrix B, then we take the sum of A plus B, which is this thing right over here, and we see it's the exact same thing as matrix B plus matrix A. Now let me ask you an interesting question. What if I wanted to subtract matrices? So let's once again think about matrices that have the same dimensions. So let's say I'm going to have two 2 by 2 matrices. So let's say it's 0, 1, 3, 2. And from that, I want to subtract negative 1, 3, 0, and 5. So you might say, well, maybe we just subtract corresponding entries. And that indeed is how you can define matrix subtraction. In fact, you don't even have to define matrix subtraction. You can let this fall out of what we did with scalar multiplication and matrix addition. We could view this as the exact same thing as taking 0, 1, 3, 2, and to that we add negative 1 times negative 1, 3, 0, 5. And if you work out the math, you're going to get the exact same result as just subtracting the corresponding terms. So this is going to be, what is this going to be? 0 minus negative 1 is positive 1. 1 minus 3 is negative 2. 3 minus 0 is 3. 2 minus 5 is negative 3. And you'll see that you get the exact same thing over here. When you multiply negative 1 times a negative 1, you get a positive 1. Positive 1 plus 0 is 1. Negative 1 times 3 is negative 3. Plus 1 is negative 2. Fair enough. There might be a question that is lingering in your brain now. Okay, Sal, I understand. When I'm adding or subtracting matrices with the same dimensions, I just add or subtract the corresponding terms. But what happens when I have matrices with different dimensions? So, for example, what about the scenario where I want to add the matrix 1, 0, 3, 5, 0, 1 to the matrix, so this is a 3 by 2 matrix, and I want to add it to, let's say, a 2 by 2 matrix, 5, 7, negative 1, 0. What would we define this as? Well, it turns out that the mathematical mainstream does not define this. This is undefined. This is undefined. So we do not define matrix addition or matrix subtraction when the matrices have different dimensions. There didn't seem to be any reasonable way to do this that would actually be useful and logically consistent in some nice way.
So that is the really important part to take from that is you can only add or subtract matrices that are the same size. 2 by 3s, both of them. 3 by 2s, both of them. 4 by 1s. They both have to be the exact same dimensions. Otherwise, it's undefined. You cannot add them together if they're not the same, because they have to be the first row, first column, first row, second column, first row, third column. You add the same position together. If they're not the same dimensions, you might not have a first row, third column in the second one. So how do you add it? You cannot. So you have to do it when they're the same size. All right, let's go back and see what it says. So that was the video. So we can go back from there, and that's done. Let's look at the lesson that goes with this, where we can make sure we're logged in. Close that little half window. Yep, I'm logged in up here in the corner. Adding and subtracting matrices. They always do a little review that this is a 2-row, 3-column matrix. That's important to review that because they have to be the same size to be able to add. So what we're going to learn in this lesson is as long as the dimensions of the two matrices are the same, we can add and subtract them just like we add and subtract numbers. So here's a nice one. Add matrix A to matrix B. So here's A, here's B. You bet, Grant. Find A plus B. We can find the sum by simply adding the corresponding entries. Here's A plus B. Here's A, here's B. So up here in the corner is 4 and 1. So we take 4 plus 1. The second one in the first row is 8 and 0. Add 8 plus 0. Down in the second row, 3 plus 5 and 7 plus 2. So adding these together, we get 5, 8, 8, 9. Pretty simple. Single digits being added together as long as they're in the same place in the matrix. All right, let's see how we can do. Can I make this a little bigger? Yeah, that's big enough right there. All right, what is the first row going to be for our new matrix when we add A and add B? What's the first row? You can give me all 3 rows if you want to, but right now I want at least the first row. Right? So the first number right there. Take the first number in this first row. Take the first number in this first row. 7. Oh, okay, wrong number. 7. 5 plus 2. And then 2 plus 3. Doesn't get any easier than this, guys. I'm asking you to add 2 plus 3. That's probably the easiest we're going to get here in an Algebra 2 course. All right, second row. Well, maybe it's going to get easier because I'm going to get to 1 plus 1 here in just a moment. 0 plus 4 and 1 plus 1. All right, third row. Yes, we have a 1 plus a 0. We have a 9 plus a 2. I think you guys are going to be able to blow through this assignment and make it real easy because you got that. Well done. How about this? Adding this. What are these 4 numbers going to be? It's a little trickier. We're not adding 1 plus 1 anymore, but come on, guys. Algebra 2, you guys. This is not a problem. It is kind of fun going back and doing elementary school math again for a little while. Just doing it in matrix form. All right, Ethan's got 4 answers. Negative 10 plus negative 1. That's the term. You got to look at the first one here and the first one here. Negative 10 plus negative 1. If you can get that one, the rest get even easier. 12 and 4. Negative 6 plus 22. Yep. Negative 6 plus 22. That is 16. And 3 plus 7. So we got a couple of 16s because we had 12 plus 4 and negative 6 plus 22. That's right. All right, let's move to subtracting. Subtracting works just like addition. They have to be the same size. And you just simply subtract the ones that are in the same place. The 2 and the 5 is 2 minus 5. It ends up negative 3. 8 minus 6. 8 minus 6. That's 2. And the second one, the rows work the same. So let's check this one. Here's our problem. 4, 16, 10, 22, subtracting 115, 6, 3. What is this matrix going to be? Getting trickier now. We're subtracting 4 minus 1. Well, I think I've got a lot of you lost already. You're like, wait a minute, Mr. 4 minus 1. Is that 11? All right, wake up. This is the class participation portion. Some of you may be already working on the assignment. That's not a bad thing if you can do the assignment already. Yeah, 4 minus 1 is 3. 16 minus 15, 1. 10 minus 6. And 22 minus 3. It's not that tricky. All right, you got that. Good job. Here's a bigger one, 3 by 3. That's our last problem. Nope, we got one more. Well, we're going to look at one more thing. Okay, we can do this a row at a time here. Let's do this row at a time. So the first row, subtracting 3 minus 1, 2. We got a theme going here. 4 minus 6, negative 2. So we've got positive 2, negative 2. And then 9 minus 7. Okay, we got a lot of 2's, some positive, one negative. Second row, we got a 686, subtracting a 642, subtracting 0, 4, 4. Well, a lot of repeats in this answer matrix, isn't it? Okay, 734 minus 415. Oh, this is our countdown row. 3, 2, negative 1. All right, how do we do? Perfect. Let's talk about scalar multiplication just a little bit. And you understand this concept because we learned this a long time ago too. But if we wanted a times a, I'm sorry, plus a plus a plus a, right? So if I ask you, hey, add 5 plus 5 plus 5, there's probably a whole lot of you that would not add 5 plus 5 plus 5. You just go, oh, that's just 5 times 3. That's 15, Mr. Rock. That's 5 times 3. 5 plus 5 plus 5. That's just 5 times 3. Same thing. Well, it's the same thing in a matrix as well. If I said add this matrix and add this matrix and add this matrix, you might go 4 plus 4 plus 4, but you'd probably do 3 times 4. Because that's the same thing as 4 plus 4. And you might do 8 plus 8 plus 8 or 3 times 8. So when we add the same matrix multiple times, a plus a plus a, it's really the same thing as just doing scalar multiplication. It's really 3 times this matrix. Instead of adding that matrix 3 times, we'll just take 3 times that matrix and find 3a. So a plus a plus a is the same thing. It's just multiplying 3 times each number in the matrix. And subtraction would kind of be like adding the opposite, right? A minus b is the same thing as a plus a negative b, or negative 1 times b. All right. Let's go back and look at our assignments now. We've looked at those two. Let's do the add and subtract matrices assignment. Now, if you're wondering where to turn this in, some people get confused with that. When I click and go there, this is the page where I turn it in. Same place that I went to the assignment. So when I get back, I'll just scroll down and turn it in right down here. Close this. Ready to practice. Let's go. Here are four matrices. Oh, okay. Which of the following calculations are possible? Oh, so we're going to make this smaller. So looking at these, first let's look at, can we add A plus B? Here's A and here's B. Can we add this matrix to this matrix? Well, this has two rows, one, two. This has three rows. They're not the same size. No, you guys are getting it. I see it in the chat. So we know that this one's out. Can we subtract A minus D? A minus D. Here's A. D is this one down here. So this is a 2 by 3 and D is a 2 by 3. That should be possible. How about B plus C? Could we take B and add it to C? Is that a possible calculation? Hmm. B is a 1, 2, 3, 3 rows, 2 columns. C is a 1, 2, 3 rows, 2 columns. Yeah, that's possible. We could do that. How about C minus A? Here's C. Can we subtract A from C? So good job. This is the very first step in adding and subtracting with matrices, is figuring out, can I even do it? And no, we can't do that. So we're only doing B and C. A and D are incorrect. Check. Nice work. All right, let's do the next one. This one we're actually doing the subtraction. That's a minus. 1 minus negative 1. So let's see what's our answer going to be. 1 minus negative 1. So when you subtract a negative, subtract a negative, remember that's the same as adding. Ethan's got this. He's going to do well in this. So it's 2. What's 1 plus 1? 0 minus 1. Minus 1. That one's not too bad. Negative 2 minus 3. So we have a negative and we're subtracting 3 more. Negative 5. Negative 1. This is probably the most confusing one. Negative 1 subtract negative 2. Yeah, if we're subtracting a negative 2, that means we're really adding 2. So negative 1 plus. That is a positive one. Good job. Thought that might get you guys. Great work. Next question. All right, we're just adding these two together. This is probably our simplest one so far. We're just adding them together. Negative 1 plus 3. 4 plus 2. I'll go ahead and do this one pretty quick. 4 plus negative 2. And 3 plus 1. And together. Next question. Okay. This is like the one we had on the quiz. Find the values of x and y. Here's x. What are we doing with these? We're adding them together, and the third one is what it equals. So what is x going to be? Oh, good job, guys. So we add it to 1, and we end up with 1. Well, the only thing we can add to 1 would be 0. Okay, and then the y is right here. 5 plus something equals 9. Hey, I'm liking this. Beautiful. Show our summary. 4 out of 4 complete. Oh, they're doing their fundraising drives right now. Support Khan Academy. All right, I'm going to close that. We're going to scroll down, paste it right here on the same page. Submit. Don't forget to submit. That assignment's now done. Let's do matrix equations. This is a little different. Click. Close the little half window. All right, let's make this a little bigger. Solve for x. This is a little different. We have a matrix. X is a matrix, but we have to give the entire matrix. And here's what it equals when added to the existing matrix. So we have to figure out all four of these that would be matrix X right here in the middle. These are fun. Yep, there you go. All right. 4 plus X equals 6. And you can write that out if you want to. You could do 4 plus X equals 6. If it confuses you, write that out on paper. 4 plus X equals 6 and solve for X. Well, X must equal 2 because 4 plus 2 equals 6. Negative 5 plus X equals 3. Negative 5 plus X equals 3. Little trick here. We start at a negative, we end up at positive, so we must have to add more than 5. We're adding 8. You can always subtract if you need to. 6 minus 2 equals 4. 3 minus 8 is negative 5. 9 plus X equals 2. So X must be a negative number if we're adding it to 9 and getting something smaller, right? How much smaller is it? Negative 7. Negative 2 plus something equals 11. Negative 2 plus 13 equals 11. All right, got another one. What's this going to be? We have this matrix. We're adding X, which is right here. And this is what we get when we add them together. What's the first row? 4 plus something equals negative 3. 4 plus something, negative 3. Yeah, 4 plus negative 7, right? Because we got to subtract 7 to get there. So we're going to add a negative. Negative 4 plus something equals positive 4. Good job. 2 plus something equals 6. Yeah, 2 plus 4 equals 6. All right, that's the first row. Now we've got 8, 7, and 1, negative 17, 9, and 18. 8 plus something. Ooh, this is a good one. 8 plus something equals negative 17. Eight plus something. Yeah, negative 25. Got to be negative, big number, negative 25. And then we've got 7 plus something equals 9. Okay, that one we know how to do real easy. 1 plus something equals 18. Marvelous. All right, what do we got now? Raise it just a little bit. Oh, we've changed it on you. Look at that. We're subtracting X. We're subtracting this time. So we're taking the first matrix, subtracting the one we're filling in, and it's going to equal this one on the right. So 2 minus something gives us 0. Oh, okay, Mr. Brock, that's not so hard. 2 minus 2 equals 0. All right, let's try this. What would I have to subtract from 2? 2 minus what? Would give me a positive 6. It got bigger. We subtracted something from 2 and it got bigger. The only way that could happen is if we're subtracting a negative number, right? Because if you subtract a negative, it adds. So it must be -4. -7 minus something equals a +15. Ooh, that's a big one there. -7 minus -22 would give us a +15. So there's the first row of our answer. Second row, 8 minus something is -9. So 8 minus 17. 5 minus something gives us -18. So that's going to be like what, 23? 1 minus something gives us a 19. Well, if it gets bigger, you're subtracting a negative number. So it'd be 1 plus 18 would be 19 minus negative. 3 minus something equals 12. 3 minus a -9. Because again, subtract a negative, it adds. 12 minus something gives us -7. So the 12 goes all the way down to 0 and then 7 more. So we must be subtracting 19. -15 goes up to 3 when we subtract what? We subtract a -18. I think that should be right. Let's see. That was a lot. It's thinking. Oh, we got it. Oh, we earned a bonus question. Oh, did I miss? I didn't answer anything on the first one, I guess. Okay, we'll get a bonus question. It doesn't show a check mark like I skipped the first question. All right, bonus question. Didn't know I skipped it, but apparently I did. Okay. I think the bonus question is giving me a chance to get 4 out of 4 without having to start over. I think that's what the bonus. So it is kind of like a reward. If I get the bonus question, I think it'll give me 4 out of 4 because I was 3 out of 4, which is a lot better than having to do 4 more problems. I can do 1 more problem as long as I get it right. 4 plus x equals 7. So that would be 3. -21 plus something gives us -16. So that would be 5. Ethan's on top of this. 3 plus something is 12. That must be a negative number then. 6 plus something is 19. 8 plus something is 1. So that's going, must be adding a negative number if it goes down. And -9 plus something is 0. So -9 plus 9. Show the summary. Yeah, it gives me 4 out of 4, where I would have missed one because I skipped it apparently. So I don't have to start over. Look at that. Bonus question. Scroll down, paste that. I'm happy you didn't have to take 4 more problems. Okay, that finishes this first folder in week 27. So I'm closing that. Now we're just multiplying matrices by scalars, video lesson, and then those 2 assignments, which are real similar to what we just did. We're just talking about multiplying this time. Okay.
Now that we know what a matrix is, let's see if we can start to define some operations on matrices. So let's say I have the 2 by 3 matrix, so 2 rows and 3 columns, and the entries are 7, 5, -10, 3, 8, and 0. And I want to define what happens when I multiply 3 times this whole thing. So first of all, let's get a little terminology out of the way. The number 3 in just the everyday world, if you weren't dealing with matrices or vectors, and if you don't know what vectors are, don't worry about them just now, you would just call that a number, or you would call this a real number. It's just a regular number sitting out there. But now in the world where we have these new structured things, these matrices, these arrays of numbers, we will refer to these just plain old real numbers that aren't part of some type of an array here. We call these scalars. We call this a scalar. So essentially what we're defining here, we don't know, I haven't said what this is actually going to turn out to be, but whatever this turns out to be will be a product of scalar multiplication, or we're multiplying a scalar times a matrix. And so how would you define this? What do you think this should be? 3 times this stuff right over here. Well, the world could have defined scalar multiplication however it saw fit, but one way that we find perhaps most obvious and most useful is to multiply this scalar quantity times each of the entries. So this is going to be equal to 3 times 7 in the top left, 3 times 5, 3 times negative 10, 3 times 3, 3 times 8, and 3 times 0, which will give us, it didn't change the dimensions of the matrix, it didn't change, I guess you could say, the structure of the matrix, it just multiplied each of the entries times 3. So the top left entry is now going to be 21. The middle entry, or the entry in the middle row top column is going to be 15, negative 30, 9, 24, and 0. So when you multiply a matrix times a scalar, you just multiply each of those entries times that scalar quantity.
There you go. Scalar multiplication is that simple. Just multiply by the number you see there. So if there's a negative number, you just make multiply by a negative number. So let's take a look now at the lesson that goes with this. All right, close this little half tab. I probably need to make this smaller for the lesson. This reminds us that this is 2 by 3. Again, remembering what size dimensions. Matrix elementary entries, these numbers. So what we're going to learn this time is we can multiply matrices by real numbers, scalars, and scalar multiplication. So when we work with matrices, we refer to real numbers as scalars, like we're scaling it up times 2. So we multiply it by 2, whatever. The term scalar multiplication refers to the product of a real number in a matrix. So in scalar multiplication, we just multiply each entry by the scalar. So if we have this matrix A and we want to find 2A, to find 2A, we just multiply everything times 2. So it is that simple. If we have this 10, 6, 4, 3, and we're trying to find 2 times that, 2 times 10, 2 times 6, 2 times 4, 2 times 3, we can see how this becomes this. All these numbers are twice as big. These are all twice as big as the original because it was just multiplying times 2. We scaled it up times 2, scalar multiplication. All right, let's see if we got this. Find negative 3b. Negative 3b for this matrix B. So we're just going to take those 4 elements, starting with negative 4, and we're going to multiply it times negative 3. So negative 3 times negative 4, negative times a negative, 3 times 4 is 12. We've got negative 2 times negative 3. Negative 2 times negative 3 is a positive 6. What's your positives and negatives? Remember, this is a negative we're multiplying by. Negative 3 times 7, negative 21. Negative 3 times 1. Okay, that's the only thing that's tricky about this is if this is a negative number, make sure you change all the signs. This was negative, negative, positive, positive. Now it's positive, positive, negative, negative. Check. There you go. Oh, look at this. Find 1/3 C. 1/3. Multiplying by 1/3 is the same as dividing by 3. we could divide by 3, and that's the same thing. Multiply times 1/3. So negative 42 multiplied by a third. You can get a calculator out if you want and do that, but it's negative 14. What's 1/3 of 27? What's 1/3 of negative 3? So 1/3 of that, 1/3 times that. Check. All right. And that's the end of that lesson. So now we just have the two assignments, multiplying by scalars. Ready to practice. Find the value of x and y. X is right there. Y is in the answer. There's an equal sign right there. So we're taking one negative 1/4. Notice the negative out front. There's a negative times x, and we're getting 5. Negative 1/4 times x gives us a positive 5. So x has to be what? If you're not sure, you could divide. That may not be easier with a fraction, though. Well, if this is a negative and we're multiplying it by a number and we end up with a positive, that means our number has to be a negative. A negative times a negative would end up with a positive. All right, so what's a negative 1/4 times? Oh, let's see. Y is over here, so that would be negative 1/4 times negative 32. Negative 1/4 times negative 32. So that would be a positive because it's a negative times a negative. And what's 1/4 of 32? It's 8. Oh, you can show a calculator there, I guess. So if you need a calculator, they have one you can use. That's nice. Check. Okay, that one's right. Next question. Oh, we just have to put the answer. Look at there, and it's being multiplied. They like these negatives today. These are all random that it generates. Negative 2. So negative 2 times negative 1, negative 2 times a positive 3, negative 2 times a positive 4, negative 2 times a positive 2. So the main thing is make sure you get your negatives correct. This is a negative, so that means everything changes signs. Positive, negative, negative, negative. Find x and y again. Okay, here's x and here's y. They're together. We're multiplying times negative 2. So negative 2 times x equals a positive 8. That means x is a negative because negative times a negative will give a positive. And 2 times 4. Negative 2 times y equals 0. Oh, that's a good one. What is y if negative 2 times y equals 0? Put that in the chat. What do we multiply times negative 2 to end up with 0? They're getting tricky on us. Yeah, there's only one number that you can multiply by to get 0. And that's 0. Y must be 0. Negative 2 times 0 is still 0. All right, last question. 1/5. You do have that calculator if you need to use a calculator. 1/5 is the same as dividing by 5, multiplying by 1 divided by 5. So 15 divided by 5. Oh, I didn't hit the button in between there. All clear. 15 divided by 5. Or, if you're not sure, you can do one, put 1/5 in parentheses. 1 divided by 5. Oh, that's the wrong. 1, where's it divided? That's it divided. Is that in parentheses? Oh, it won't back up. There, 1/5. times 15. I'll hit times 15. See, 1/5 times 15 is 3. It's the same thing as dividing by 5. 3. -1, -2. At least they give nice answers here that are not fractions. 20 divided by 5 is 4. That would do. Yay! Show summary. I caught the confetti that time. Although I should have scrolled down, but that's all right. Got it. Okay, what's left? Just matrix equations. Click on this, close this little half page. Ready to practice the matrix equations. We have to put the entire matrix for x in there. So this is a little trickier. It's 2 steps. Not only are we multiplying 3 times x, we're also adding another matrix to it to get this final answer. To get that final answer. So let me show you a good way to break this down if you're a little confused. If we're looking for this first box, all right, so we're trying to get this one right here. If we look at the matrix, it's going to be 3 times x plus -1 plus -1. I'm kind of putting that in parentheses, kind of equals -13. 3 times x, and x is going to be 9 different things. But the first time, oh no, I see what's doing. We're not going to use all of this. Our answer is only a 2 by 2. See how that's gave it? The answer is too big. Since our matrices are only 2 by 2, our answer is only going to be a 2 by 2. So if we wrote this out on paper like this, 3 times x plus a -1. So if we subtract -1, which let's simplify this. 3x minus 1. Adding a -1 is the same thing as 3x minus 1. If we add 1 to both sides, alrighty, we've got 3x. Adding 1 makes that -12. Then we just divide by 3, and we can see that x equals -4. Because -12 divided by 3 is -4. So that gives us what x is. All right. Let's try it again. But now we need to get the second one. So 3 times x plus a -2. So let's just simplify that to -2 equals -2. I'm using this one and this one because we're trying to get the second. All right, we're trying to get that one. 3x plus -2 equals -2. Add 2 to both sides. Three x equals 0. Terrible 0. 3x equals 0. So when we divide by 3, that's going to be 0. 0 divided by 3 is 0. All right. Second row, this one down here. 3x plus 10. Ethan's ahead of us. Equals -5. Subtract 10. Good job. You guys are starting to get this. 3x equals negative 15. Divide both sides by 3. So that is going to be negative 5. 15 divided by negative 3. Then you got 3x minus 7 equals 14. Because we added a negative. Adding a negative is the same as subtracting. So we add 7 to both sides. 3x equals 21. So x equals 7. Okay. If we're adding to a matrix that's a 2 by 2, the answer has to be a 2 by 2. So yeah, if this is a 2 by 2, x has to be a 2 by 2. Let's see what happens. Okay, it's counting it right. But I have seen in the past where that has glitched and said nope, because it wants you to fill in everything. So as long as it's working good, if not, if it glitches, take a picture of the glitch and I'll give you credit. All right. 3x. This is just like the last one. 3x plus this equals this. So let's look. 3x plus 11. So 3x plus, I'm sorry, plus negative 1. So 3x minus 1 equals 11. If we add 1, it's 12. So that'd be a 4. 3 times 4 would be 12. Minus 1 would be 11. Okay, I like that. 3 times 1 plus 1 equals 4. I just did that one in my head. This one's a 0. So 3x equals 9. 3x equals 9 is 3. So the first row should be 4, 1, and 3, I believe. 3x plus 8 equals 2. So we would subtract 8. So 3x equals negative 6. Not taking the time to write all these out on the screen, but you could do that. 3x plus 8 equals 2, and then solve that equation. 3x minus 5, which means I add 5 to this. So 3x will equal negative 12. So that should be negative 4. See, 3x plus 9 equals 0. So if we subtract 9, 3x equals negative 9. Okay, negative 3. 3x plus 4 equals negative 14. So if we subtract 4, that'll give us negative 18. So 3 times negative 6 would be negative 18. 3x plus 3 equals negative 12. Subtract 3, negative 15. Lots of negatives on this one. 3x minus 1. So if we add 1, we get 6. So 3x equals 6. Must be 2. Let's see how that goes. Okay. And to get trickier, I'm going to work the first one out on this. Hold on. I'm going to use my non-disappearing ink. Okay. So this first is 1/5 x plus 4 equals 9. So I would write it like this. Plus 4. You bet, Angela. Okay, we're going to solve this for x. All right, we got this x right here. The first thing we have to do is move the 4. Because you're looking at this fraction going, oh my gosh, how do we do this, Mr. Brock? Except Ethan, he knows how to do this. Good job. So when I subtract 4, I got 1/5 x equals 5. This is not difficult once you get to this point. Now remember, the very first thing you have to do is you have to move this to the other side. But once you get x by itself, if I want to get rid of this fraction, multiply it times 5. 5 times 1/5 is 1. Multiply this times 5. So this is x equals 25. 5 times a fifth is just x. So that answer is actually 25. So the 1/5, you just end up multiplying by 5 when you get it by itself. 1/5 x plus 7 equals, oh, let me clear this out. It's going to get confusing. Okay. 1/5 x plus 7 equals negative 4. So when I subtract the 7, I've got negative 11. And then I'm going to take it times 5. So that should be negative 55. All right. That's what Lawson got also. So I'm feeling good. Now notice this is a 3 by 2. So our answer should be the same size right here. They put an extra column to try to trick you. There's nothing goes over here. Our answer is the same size as the two matrices we're adding together up here. 1/5 x plus 2 equals negative 2. If we subtract 2, we're going to have negative 4, and then we'll multiply it by 5. So that's going to be negative 20. The next one, we're doing the 1. Subtracting 1 gives us 7. And then we're going to take that times 5. So we're doing 35. Is that right? Because it's, yeah, it was plus 1. So we had to subtract that. So 1, it would be 7. 5x plus 8. So if we subtract 8 from negative 3, that's negative 11. So we take that times 5. We got negative 55. You can double check me, guys. Make sure I'm right on that. Lawson had a different answer there. 1/5 x plus 6. If we subtract 6, 7 minus 6 is just 1. And then we take that times 5. It should be that. I think that's right. Okay, good, good, good. 1 to go. And this one is a 3 by 3, so all of that will be valid. This is a minus this time. Minus right there, so we need to remember that. So this would be like the first one would be negative 2x minus 8 equals negative 18. We'd add 8. Pretty sloppy now. I need to get my little pen out. I have a pen I could do this with. Right? Then we divide by negative 2. So this would be a positive 5. Negative 10 divided by negative 2. Let's see. Add 4, because this is being subtracted. Add 4 would be 6. Negative 2x equals 6. So that means that has to be negative 3. Then we subtract the 4. So we add 4 to 22. That gives us 26. Divided by negative 2. Okay. Negative 2x minus 1. This one was just straight across. So we add 1 to 9. It's 10 and divided by negative 2. So that's a negative 5. Okay. Now we're starting to get the confusing ones. We've got negative numbers over here. So let's take that into account. If we have a negative 5 and it's a negative here, so that's negative 2x plus 5 equals negative 25. So that is this row, the middle number is what we're trying to find, the middle number right there. So subtract 5, which means this is now negative 2x equals negative 30. Negative 2, so that's going to be a positive 15. Because we're dividing by negative 2. Negative 30 divided by negative 2. Okay. Negative 2x minus a negative 9. So this is negative 2x plus 9. So all these negatives, you got to be careful. So that's why I'm writing this one out. Because we had a negative 9. It equals negative 17, We subtract 9, negative 2x, negative 9, negative 17 is negative 26. So negative divided by negative, that's going to be a positive 13. Okay, hopefully that's right. Minus 3, so we'd add 3, that's going to be 18 divided by negative 2. This one's a little back to the simpler ones. This is a minus 2, add 2, there's 14. It's going to be negative 7. And we have a 0. So negative 2x equals 10. That's the nicest one they did to us there. Show summary. And that's the end of this week's assignments right there. Let's take that, go back here, scroll to the bottom, paste that in there, submit. And when you've got to that point, should show everything check marked in this folder. Oh, let me get rid of that on the screen. And we're done. So if we want to go back and double check our grade screen, we see everything that has a due date of this Sunday has something submitted, complete, submitted. It just needs to be graded. It's complete, submitted. That's what we got this guy. Got 4 matrix things this week. Just pay attention on the fractions and the negative signs because that can mess you up. But otherwise, I think you guys got this. It's just adding and multiplying numbers. Just got to be tricky if they put negatives in there or if they put a fraction. Remember, if it's 1/3, you multiply by 3. If you multiply 1/5, you multiply by 5. But just get it by itself before you do that. So if you get negative 1/5 x plus 1 equals something, move that 1 first and then just multiply by 5 and that'll get it. Or if it's a negative 1/5, you can multiply by a negative 5 to make it a positive. But that's what you got. You have these 4 assignments and that'll wrap it up. Next week we're just going to have a matrix quiz to finish it up, and I don't think it's going to be like a supersized quiz, but that will wrap up matrices. So if you got questions, come see me Wednesday. Some of you may be missing enough that you have to come Wednesday anyway. So be sure to look at RTI. If you're missing stuff and your grade is below 70, then I'll see you Wednesday anyway. Otherwise, you can come get help if you need it Wednesday. Have a great week, guys. You got the rest of the period. Hope these 4 assignments done. Be done for the week.